Okay, good evening, everybody. You're on to Mamu with Jarvis, and this is our Midnight Sun experience. All right, so that'll be the Midnight Sun project. And I might trust you've seen the Wakanda Forever, and for me, it was mind-blowing. Wow, awesome concept. In fact, it shows how good Africans can be when it comes to developing movies. I want to advise you to look up The Woman King. The story part, not so different, The Woman King. Try to look at that. But for today, we'll keep it algebra as we go into the matter of algebra. Quick reminder here that our pattern is to go through past questions, and we'll be looking at quadratic equations. So to kickstart our experience today, I'll be looking at WAEC June 2011 OBJ. WAEC June 2011 OBJ. So let's look at if there are questions there that pertain to quadratic equations. So today we're looking at quadratic equations, and in every WAEC year, usually would have maybe one or two questions that are quadratic in nature. So for this year, 2011, I'm trying to go through to see if there's any question like that. Okay, there is one. Look at question number 16. Testing your knowledge of forming quadratic equations. Now, you can form a quadratic equations by being given roots. The roots will develop factors which we can multiply to obtain the equation. Come again, the roots we can multiply to obtain the equation. So we are told that form the equation equal to half and what? -2/3. So what this invariably means is that x is equal to 1/2, or what? X is equal to what? -2/3. X is half, x is -2/3. The first thing I want to do is to multiply both sides by 2. This will give me 2x equal to 1. I multiply both sides by 3 because we are doing this to clear the denominator. 3x equal to -2. The next thing I want to do is to what? Make this a fraction, all right? Make this what? Make this an expression, or what's the right word to use? Make this a factor that is equal to 0. So this becomes 2x minus 1 equal to 0. Slave-king relationship, or 3x. Since this is negative, it becomes plus 2 equal to 0. The next thing I want to do, if this is equal to 0 or this is equal to 0, it will mean that 2x minus 1 into 3x plus 2 will obviously be equal to 0 as long as I hold one of the variables constant, or hold one of them per time. So this will now be what? This will multiply the content 2x multiply 3x plus 2, and -1 will multiply what? 3x plus 2 equal to 0. We can open this up. This becomes 6x squared plus 4x. Negative multiplies this, means that every term here will turn to negative because these terms are positive. So negative what? 3x minus 2 equal to 0. We collect like terms. So 4x minus 3x will give me what? X. So I'm going to have 6x squared plus x minus 2 equal to 0. And so we have been able to form what is called the quadratic equation in that question. So that question will require to form the quadratic equation there, and we have done that successfully. Just want to quickly do a flip to see if there are other questions like that in this setup. And then, interesting enough, we don't have any other question or questions like that. So we would retire from this question paper and we'll try to take another question paper, right? Usually you just get maybe a question or two. In this exam setup, you just get a question or two from them. All right, so let's go to the next one. The next one is November, November 2004, and it's another OBJ exam. So as usual, we could flip to the question paper. And if we do that, let's see where we can have that question coming up. Yes. Let's see. Sorry, 1 minute. Okay. All right. Now, in this question, although I'm treating quadratic equations, if I see quadratic equations that tend towards, or rather, if I see quadratic expressions, I may be compelled to look at them. So if you look at this question, look at question number 17. Question number 12, rather. I will solve this because it says 3p squared or 3p minus q squared minus p minus q all squared. Remember that when we start the concept of quadratics in your grade 9, we would usually deal with the concept of difference of two squares. The whole matter of difference of two squares says that if I have a squared minus b squared, it is the same thing as saying a plus b, add the terms and subtract them. Add the terms, multiply by what? Subtracting them. This is not a direct quadratic equation, but it's important you understand this concept. So with that, I'm going to have something like, say, I'm going to add the terms, that's 3p minus q plus p minus q. I'm going to subtract the terms, that is 3p minus q minus affecting this one. Are you seeing that? So this will give me what? 3p plus p will give me 4p. Q minus q will give minus 2q. And then let's look at this. I'll need to open this one up. This will give me 3p minus q minus p plus q. Is that okay? And this will now give me 4p minus 2q into what? 3p minus p will give me 2p, and negative q plus q will give me 0. So this will be my likely answer there. This will be my likely answer there if I have done the right thing. Except there's something in this problem I have missed. Okay, addition. This will give me 4p minus q. This will give me minus plus, beautiful. So this is 3p minus p. That will give me 2p. And this will give me 1. All right, so that should be what my answer would be. All right, so this invariably, if you're doing an exam setting, I can factor 2 out. So that will be 2 times 2p into 2p minus what? Q. And that will give me 4p into what? 2p minus q. And that will take care of that problem. So let's allow ourselves a little bit of breathing space, and then we process what we have done so far. Okay, still on that same year, we have another that says what? So we're dealing more with more quadratic equations and what? Expressions. Still on that same year, it says question 13, factorize 3p squared plus 2p minus 1. So the first thing you need to look at is what? The sum of factors and the product of factors. So the sum of factors would have given me what? 2. The product of factors would have given me what? Negative 3. So what are the factors I'll be looking for? Now, to look for factors, I will consider the products. This is positive 2, this is negative. So I'm going to consider factors like negative 3, or rather positive 3 and what? Negative 1. This is one of the possible occurrences that will give me what? Negative 3. So once I have this, I will transpose this idea here. This becomes 3p squared plus 3p. Okay, let's say minus p plus 3p minus 1. Now, please remember that you can use the other pattern. It's still correct, but because of years of experience, I try to avoid certain kind of narrative when I'm solving problems. All right? So this will give me p into 3p minus 1 plus 1. Whenever the factors, the numbers are the same and you can't factor anything out, 1 is a factor you can factor out. And this will give me what? 3p minus 1 into p plus 1. And that solves that problem. So let's see if we have other quadratics like that. Okay. Let's see if there's any other one like that. All right. I think that's about all for that. One of these days, we're going to treat what is called algebraic fractions. And perhaps we'll be able to see more questions relating in that dimension. All right, so I think that settles that one. That takes care of that, and we are done with that question. So we come to 2021. We come to 2021. We come to 2021. One of the things I'm planning to do after a while is to, when it's getting very close to the WAEC exam, I want to focus on the last 4 years before the WAEC exam. So you're going to see some questions that may be repeated. That's what I want to do, last 4 or 5 years before the exam. But for now, I just want to give us a general overview of okay, so this is WAEC 2021. That was last year. So let's see what were the questions in the offering for that year that looked very much like a quadratic equation. Usually every year you really have like one question. If it's not a word problem, then it could be, so let's see. All right, so you see that there's a pattern that they set in lately. They set to form equations. Now, it says that we should do what? Find. That's question number 22. It says find the quadratic equation. Find the quadratic equation whose roots are negative 2p, or negative 2q rather, and 5q. How do you solve a question like this? See, forget all the physics, a very simple question. So it means that x, root means that x will be equal to negative 2p, comma, or what? X must be equal to what? 5p, 5q. Let's say p, sorry, q, about that, q. So from this, I'm going to get factors equal to 0. It means that x, slave, becomes a king, or what? X minus 5q equal to 0. I see that if this is equal to 0 and this is equal to 0, then I can conveniently say that x plus 2q must multiply x minus 5q, and that will be equal to what? 0. Is that understood? So with that said, it means that x can multiply this bracket, x minus 5q, and then plus 2q can multiply x minus 5q equal to 0. Is that understood? So we can multiply this one out, which means that x squared minus 5qx plus 2qx minus, plus times minus is minus, minus what? 10, number, letter, q squared equal to 0. Why q squared? Q times q will give me what? Q squared. So that's understood. It will mean that what? This will be x squared minus 5 plus 2 will give me what? Minus what? 3qx minus 10q squared equal to 0. And that becomes the solution to that problem. So here they were trying to test your knowledge of algebra here. And that's what they do in modern exams now. They stretch you beyond the normal things we see. So you see that in exams like this now, you may not have more than one question that has to do with what? Quadratic. And from what I can see, this is the only question that is quadratic. All right, so we're done with this. Then we can take on the next. So we're done with 3 question papers already. Wonderful. Just having one question per exam. One question per exam. Right, so let's clean this off. Go to another question. So the next one is a NECO exam. NECO 2019. It's OBG, and it's so let's see if we can solve that one. Let's see if we can get the year concerned and see if we can solve it. So this is NECO 2019, and if I'm right, this is actually GC, so it's more of I think it's a November exam. So let's see the question that has to do with quadratic there. So let's look at that. I always tell us that as a standard practice for me, I don't solve the questions. I try as much as possible to put myself in the feeling of the exam. Could be risky because sometimes it's possible that you could encounter a question that you'll not be able to solve, but it's a risk worth taking. All right, there is one here. It says that if 2k squared plus mk plus 25 over 8 equal to 0 has equal roots. Has what? Equal roots. Find the positive value of n. The positive value of n, meaning that what that means is that if this has equal roots, we should find the positive value of n. It means that this value must be what? Positive. So how do we get a question like this? There are different ways people can use to solve this, but let's try something somewhat simple. So I'll say 2k squared plus mk plus 25 over 8 is equal to 0. Some people will simply use d equal to the square root of what? Or d equal to what? B squared minus 4ac. Some people want to use that to test if it's going to be what? Factorizable, but I can choose to divide through by 2. I divide through by 2. Does that help me? Because for it to have equal roots, it means I'm going to have, let me divide by 2. So that would mean that what? K squared plus m over 2k plus 25 over, divided by 25, that will be over 16, will be equal to 0. So there's a formula that we usually use to solve this that says that, because for us to get this is crucial to getting this. Now, to solve this, there's a formula that says that to get this one, let's go back to say let's go back to standard general quadratic equation form that what? Ax plus bx plus c equal to 0 will mean that what? X is, plus b over a plus b over ax plus k, where k is actually what? C over a is equal to 0. So it says that k will be equal to what? To get k, you get what? Half of what? Half of what? Or k squared will be half of what? Half of b over a all squared. Or rather, k will be equal to half of b over 2a all squared, which means that this will be b over 2a all squared. All right. So if that is understood, I'm just trying to give you a little background on this. It will mean that what? 25 over 16 must be equal to what? Half of m over 2 all squared. Are we seeing that? So what this invariably means is that 25 over 16 must be equal to what? M over 4 all squared. So it means that 25 over 16 must be equal to m squared over 16. If the denominators are the same, we can compare numerators. So it means that m squared will be equal to 25 and m will be equal to what? The concept of squared here in a matter of quadratic would suggest that I can have two possible values. So it will be plus or minus 5. But I have a strict instruction that the value of n must be positive. So since n must be positive, then n will be equal to 5. So that question, the answer will be what? That question, the answer will be what? M will be equal to what? 5, and that is option C. That's for question. That question is question. That should be question 29, 27, 26, 25. That will be question number 25. So we'll just pause a little to take our breaks and then, because we have quite a number of them in this question paper. I think I have seen close to like 3, if I'm right. Oh, what an exam. 4 for that matter. All right, so just quickly clean this, and then we'll go to question number 26, if I'm right. And it says that find a positive value of x for which 12x squared minus 4x over x squared minus 2x minus 3 is equal to, is not defined. When they say an expression is not defined, it will mean that that expression is equal to 1 over 0. An expression is said to be not defined if the expression is equal to 0, equal to 1 over 0. In such a setup, what the interpretation of this is that it means that equate their denominators. When you're given an expression that is not defined, it simply means what? Equate their denominators. Don't go into the trouble of trying to figure out what they're talking about. It means simply do what? Equate their denominators. And if you do that, it will mean that what? The factor, this is -3, this is -2, -3, -2. So the sum of the factors is -2, and the product of my factors will be what? -3. So what are the factors I'm going to consider? One has to be negative, one has to be positive. Now, because this is -3 and this is -2, I will consider -3 times 1. Then that is settled, I will have x squared minus 3x plus x minus 3 equal to 0. I can factor x out from this first one, x into x minus 3, and I can factor 1. Where no factor exists, 1 will definitely exist, plus 1 into x minus 3 equal to 0. So that will mean that what? X minus 3 into x plus 1. I take this one out, I'm left with x. I take this one out, I'm left with 1. Will be equal to 0. And as such, x minus 3 is equal to 0, or x plus 1 equal to 0. Remember that we are told to find what? The positive value. So I don't need this part. All I need is this part, so x must be equal to 3. So that solves that question. That will solve that question for that. And we can then go to another one that says factorize. That's in year 27. This year they have so many of factorize 3x squared plus 5x minus 8. We're told to factorize that. So how do we go about that? We take the sum of the factors, which will be what? 5x or 5. I just prefer to use the number alone. The sum of the factors is always the middle term. And then the product of the factors obtained by multiplying this and this, now be -24. So what will be the factors? The factors will be thinking of two numbers that when I multiply them, I will get this. And when I add them, I will get this. Now, if you look at this number is an odd number. And that suggests something that one of the factors I need must be odd and the other must be even. So this will give me what? I think of 8 and I think of 3. What's my combination? This is positive, so this will be positive and this will be negative. So I can rewrite this to be what? 3x squared plus 5x plus 8x minus 3x minus 8. Okay, I decided to go against my rule here. And this will give me what? X into 3x plus 8 and -1 into 3x plus 8. Remember that if you're using this rule I have broken, your factors must be such that they make this look like this. All right, so this will now be 3x plus 8 into x minus 1. And that will solve that question. That's question number 27. All right, so I had in mind that today's class was going to be a very short one. It's going to be a very short one. My plan was to have the class for like 30 minutes, be out for a while. So I will trust that you go back, look on these videos and see how much improvement you would have made by studying my video. I'll return shortly. I'm having a little challenge with some logistics and some other stuff, but I'll promise you that it is Mamu with Jarvis, the Midnight Sun project forever.